In this video, we're going to go over the last 3 questions on your Chapter 6 review, where we look at the applications of matrices that we did at the end of the chapter. So one of those applications was finding area of a polygon using a determinant. Now, the formula that we went over in the video notes was for a triangle. This is not a triangle, but any shape, any polygon can be cut up into triangles. So we just have to cut this into triangles, and you could do this several different ways. So the directions here say find the area of the polygon using matrices. There's other ways you could find this area, but we want it using matrices. And so I need to split this into triangles. And you could do this one of 2 ways. You could go from here to here, one triangle, or you could go from here to here. Oops, this won't let me do this. So again, excuse my squiggly lines, but now I've got 2 triangles here. And this is the way that I did it. The first way is fine, but this is the way that I did it, so I'm going to leave that there. Now, the formula for finding the area of a triangle on a or using matrices is 1/2. Sorry, wrong tool. 1/2 the absolute value of the determinant of x, y, 1, x, y, 1, x, y, 1. And I should say this x1, y1, x2, y2, x3, y3. So we've split our, close my absolute value there. We split our quadrilateral into 2 triangles. We set up each of these matrices and we find 1/2 the absolute value of those determinants and we add them up. And so that's how I've shown the work here. This is sort of how you should show the work on the test in a couple days here. So I just said 1/2 times the absolute value of the determinant of, and here's that formatting that we're expecting for the matrix, plus 1/2 times the absolute value of the determinant of this matrix. And those again are just the 2 matrices following this format for each of the 2 triangles that we've shown. One triangle, this formatting here. And then when you do that, you get 30. So not too bad. And then the other application that we did at the end of the chapter was encrypting and decrypting messages. And so just like in the homework, just like on the test tomorrow, you're going to have one question where you're encrypting, one question where you're decrypting. So this is our encryption question. It says use the given 3x3 matrix to encrypt the message. So here's our message, online math is fun. Here's the given encryption key. And so it says show your work. Any matrices should be formatted in that same formatting technique. So my work would be to first translate the letters into numbers and enter the numbers into this matrix. A question that we addressed in the notes for this section was how do I know how big this matrix should be? Well, as it says here, please make sure you are following the conventions for encryption outlined in our notes videos. Well, our convention is that we're going to multiply this encryption key on the right, which means if this is a 3x3, when I encrypt, I don't know how big this is going to be when I start, but I know it's got to be something by 3 because I'm going to multiply this by a 3x3. And those 2 middle dimensions, when I write it out in the order of multiplication, those 2 have to match. And so once I know that it's got to have 3 columns, I know each row has 3 entries in it, and then I just go down as many rows as I need. And we saw in the notes that if this doesn't work out evenly, you just put an extra space at the end. In this case, it worked out evenly. I didn't need any extra spaces. But if I had needed, if there had been one more letter, and I'd have, 15 here in the first entry in row 7, and then I just have 2 spaces to complete the matrix there. So we do this. We put the message into letters, put it into this matrix, and then we multiply the key, which was given to us, on the right side. And when we do that, we get this matrix. So that's my answer. That's my encrypted message. It also said, though, up here, to choose at least 2 entries in your encrypted matrix to explain why this is a more complicated cipher to crack than the Caesar cipher. And we went over this question in the notes. And so one way to do this is to find entries that in the original were the same. So we've got a 0, a 0, a 0. Now when I encrypt that, and it said I have to choose 2, so I'm going to look at the 2 that are right next to each other. 0 and 0, 68 and 46. When the same letter or number in the original message gets scrambled into 2 different letters, that makes it much more difficult to crack it. That frequency analysis that they talked about in the Caesar cipher is much more difficult if I don't know if, whatever's my most common letter, in this case 0, it's actually being turned into multiple different letters, so that ruins that frequency analysis option. Another thing that we could also have addressed is that I have these 2 28s in my answer, and originally they were different numbers. So not only do you have the same number, 0 and 0, going to different numbers, but you have different numbers going to the same number. So that's another possible explanation for why this is more difficult. Okay, and then last, decrypting. So now I've given you the encrypted matrix and the key and asked you to decrypt. And so use the 3x3 encryption key matrix provided to decrypt the message. Here's the encrypted message, here's the key, decrypt, unscramble. Tell me what it really says. Show your work, format like this, like we've been doing. Follow the methods that we did in the videos. And make sure your final answer is letters, not numbers. So to decrypt, the method that we were using was to multiply the encrypted message by the inverse of the encryption key on the right-hand side. And so just explaining this is all you need to do. I know it's challenging to type too many matrices here, so I'm in terms of the work, I just want you to tell me that this is what you're going to do, and then I do want to see this decrypted. I do want to see this decrypted matrix here. So I want to see this description of the method, this decrypted matrix, and then the letters, not the numbers. So when we take these decrypted numbers and we decrypt it, and we turn it back into letters, we get this message here: CDC, WHO, NIH, COVID. So you'll have one very similar to that on your test. So if you have any questions after watching these videos, please make sure you send your teacher a message. We want to make sure that you're well prepared. This review packet should give you a good, a really, really good indicator of what's going to be on the test, how that's going to be graded, how your answers are going to need to be formatted. Should be no surprises at all.